Velkommen til Peter. Welcome to Peter that will give us a tale of software quality in the cloud.
Thanks a lot. Thanks for coming, and thanks to Mike for introducing me. Yeah, so this presentation is on software quality in the cloud, and it's sort of a tales from the trenches thing. So basically, I've been repeatedly ranting on IRC about some troubles I've been having with AWS, and in that regard, I was told that it would make for a good subject. So yeah, so I'll give a presentation overview now. First, I'll give a little bit of background about myself, and then some of my motivation for making this presentation. Then I'll talk about a service we run in production at the company I work for, called Donkey, where we experienced a rather confounding problem in December 2017. We started getting reports of crippling performance, and that coincided with HTTP2 enabling. So this talk is about how I did a lot of analysis to try to uncover the underlying problem, and we ended up paying premium support at a premium by not receiving any. So I turned to blog posting, and then that way we actually managed to have our problem priority escalate, and then by the end of the talk I'll talk a little bit about the aftermath of the acknowledgement and the outlook on problem resolution. So who am I? My name is Peter Forsberg. You can find me on IRC under the nickname PTRF, and I'm on Twitter. I'm not really that active, but there's some work-related stuff, including a link to the Medium post that made the basis for this presentation. So yeah, I'm Peter Forsberg on Twitter, and professionally I'm employed at a company in Denmark called Shotgun, and in Copenhagen I'm a backend engineer. So Shotgun is one of the sponsors here. They've provided the truck for transportation, and previous years has been fridges. So I think there's only one. This might be something I need to update, but so we were supposed to have my colleague Joachim was supposed to talk about Kubernetes, and then on Monday afternoon, the CTO of Shotgun will come, Morten. He will come and talk about algorithmically inspired design, and that should be rather interesting. So I'd recommend going there. But just so you know, I'm not really presenting on behalf of my company. Like, I'm here as a private person. I didn't even get a sponsorship ticket, but that was me being ahead of my time. So yeah. So continued. I'm from Copenhagen, as I mentioned. I've been at Bornhack since the first one. I was actually here in October 2015 when we surveyed Jarlsgaard, and we decided to have this place. I was part of that trip. But then only been engaged on the outside since then, helping out. And this year I'm a member of a away team in Hacker Jeopardy. So Heaven's Gate away team, not the Star Trek one. And then I'm a member of a dining club, and so dining club I will probably give a lightning talk about that later. It's an interesting subject, and we cook some good food. So obviously, moving on to motivation, like obviously, because this is something I've worked with, this is occupationally rooted, some of my motivation. So I thought a long time about how to write this slide, and I would just say that cloud services can be construed as an occupational hazard. So what do you want to do? You want to implement scalable API services, meaning that you want to handle peak demands of requests of many. You want to you want to be able to handle a lot of requests, and you want to not be able, you want to not look into how the physical part works. You're a company. You already do some open source development in. Particularly, we do it in Erlang and the Open Telecorn platform, which is the standard library for Erlang, and that's what we sort of specialize in. So we don't really deal with the intricacies of managing servers, and so it's a business decision to delegate that responsibility to a company such as AWS, where you pay for a service that is intended to solve this generic problem rather than the specific problem at hand, which is what is your business case. So this is the context for us having, it's not a choice that I made, obviously, or maybe not, but yeah. We're focusing on the specifics here when at our company, and so AWS provides us a means of delimiting our efforts to only focus on that, and or at least that's the claim here that we're sort of contesting. So my personal motivation, as I mentioned before, I was told when I was ranting on RSC, I was told about how this would make a good software, good talk. So yeah, so when I look at it, like most of my hacking is in relation to work, and so this is sort of like insights from a 9 to 5. And as well, case study and problem identification and analysis in like a workplace environment. I think for some here, they're not so much into programming in an occupational setting. Some may be working on open source projects, but this is rather specific to the task you're delegated to do at work. And so it's also a little bit of commentary of how no matter what fancy cloud buzzwords, whatever you throw at me, like there's still software can still be broken, and like it's just fixing it's never gonna be improved by just thinking about, oh, let's put everything in the cloud, let's reduce the issues. You're still gonna have a lot of issues, and so this is a particular case study of one of those problems. So, okay, moving on. I'd like to talk about Donkey, which is the assets upload service that I mentioned before. So this is a software service that I've been implementing, and it's really simple actually. We have Shotgun. For those of you who don't know the company, is we are a free-to-use service for people in Denmark, Norway, Sweden, Netherlands, and Poland. And we index offer catalogs, making you able to search for offers and look at what catalogs. And here by catalog I mean like Netto, Bilka, or Carrefour, if you're more internationally inclined. But yeah, so grocery shopping, supermarkets. And so our clients and ourselves, we often need to introduce, so that means persist in some way, an image or a PDF file in our system, and we want to do some validations. This could be size or content type prior to actually accepting these files. And then we want to return a transient reference, meaning a reference that is available for a given amount of time for you to do processing at a later time. So this could be resizing, rendering, whatever. Just the basics of having a data storage and database, a system that incorporates data storage and databases where you can reference these things internally. So that's it, and the API description is pretty straightforward. It's REST-ish. There's a little bit of distinction. So REST is representational state transfer, and so it's a means of exchanging over web documents and objects, and so that's perfect for us. We have a single post endpoint. that you can create a new object with, and so the content types that they accepted is multi-part form data. I didn't make that choice, but apparently that's what JavaScript needs in order for file uploads to work with Chrome. I don't know. I was told that was what I should do, so I did it, and we returned the references as application JSON. And just a little note: multi-part form data sucks. It's old Microsoft format, and like, so basically you can package multiple. You can have a single request, and you can package multiple form elements into the same request. So this could be files or text data or whatever. But this protocol doesn't really specify how many. This format, it doesn't specify how many parts a multi-part request contains, and it also doesn't specify part lengths. So, and that's just two of these issues. And yeah, so there's a little bit extra processing for me to do, but it's rather simple. It's made in Erlang, so there's a library called Cowboy, and this implements a TCP connection library facilities and HTTP2 request processing through via state machine. So this means that you can plug in at different points in the request processing, which is really neat. We don't even have Nginx. We don't have anything. We just run it straight in Erlang, and then we shell out to make use of ImageMagick and for image property extraction, and then we use libmagick to sort of get a guess that someone can probably claim here that they can come with a PDF file that my libmagick will say is a PDF file, but it's not. And yeah, that's true. But like in the most cases, we still accept this as a PDF. So we want to ensure that the content type that a request claims a file is actually the content type of the file. So these are the validations, and then we use the AWS command line tools for the API that we persist these files with in the simple storage solution. I don't remember the name, but Amazon has like this S3. So in general, you can see that we are using Erlang runtime system that contains all of our software developed for this particular problem of persisting images in PDFs. But then we use it, then we have it in an AWS setting. So it's containers all the way down. Yeah, this just a little bit about the service architecture. What I want to say is that it's built with open source software, and it solves like a specific recurrent issue. And we use Kubernetes. So the talk is not in the program anymore, which is a little bit weird. My colleagues talk. But yeah, I wanted to talk a little bit about Kubernetes reproducibility and scalability, but I don't think it makes a lot of sense if he's not going to have his talk, so I'm leaving that out. And yeah, so we leverage AWS for operation of this service and for solving the generic issues, such as providing a load balancer. So this problem I was referring to in the beginning. So basically, there's a tool called Terraform that allows you to declaratively specify how you want AWS to set up your infrastructure, which is good. And so the setup for Donkey was overhauled in December 2017, and we started. We enabled the new product, the new load balancer edition from AWS. It's called Application Load Balancer, or referred to as ELB v2. ELB as an Elastic Load Balancer. That was the previous name. And then we were like, oh, one of the added benefits is that the load balancer now supports HTTP2. So we thought, oh, that's good, that's great. So, like, the day after this was deployed into production, and like our clients started using this, our operations team, that is the ones that are handling client relations, they were reporting that people were saying, hey, this is super slow now. Whenever we try to upload a catalog, it takes forever and it just times out, nothing works. And I was like, how could that happen? So yeah, this was the day after the production deployment, and I was figuring ALB, like this ALB product, it was initially announced in August 2016, and like they announced that they had HTTP2 support, and so what's missing here is that I tried to search around and I couldn't find anything that determined like that any reports or any mentions of performance degradations when using HTTP2 for file uploads. It was just like it was as if no one had seen that before. So I was like, okay, something must be wrong with either Cowboy or Donkey, but that is also Erlang, and I can look into that. So I started looking into this, and so first I found that, well, it only affects HTTP2 requests. So any request made against the ALB, which sits in front of the service and distributes, so we can scale up, it distributes all these requests among the different Donkey servers. So whenever you would hit it with HTTP 1.1, it would perform as before, but by performing it with HTTP 2, you saw a downgrade, like a factor 3 or 4 in time in terms of response times, and sometimes you just time out. So I thought, well, let's upgrade to Cowboy 2. Before this was an earlier version of Cowboy, and I was like, okay, let's upgrade it because Cowboy 2 has HTTP2 support. It's like, okay, but it still persisted, this issue, but what we found was that if I ran Donkey and I connected to it, I made a request bypassing the ALB, then it worked perfectly fine. So now there is sort of like a way of finding out, okay, now I started like triaging where the issue was. And you gotta remember that this is something that came in from the side, because I have a lot of other projects, and then suddenly, because there's something wrong somewhere else, I have to put aside time to actually also investigate this. So this was still on the side. I was still doing this sort of like on the side while performing other tasks at work, and this, for this reason, I missed the fact in the documentation that the ALB, the application load balancer, it takes any request, any HTTP2 request, and then it translates it internally to HTTP 1.1, and then distributes it among the target instances in the load balancing group, which is, oh, okay, so we couldn't leverage HTTP2 directly. So it was futile attempts, and that was like, eventually we downgraded to the elastic load balancer, and I was told to continue to investigate the problem whenever I had time, but we had like some stepping around, and I found that, okay, I needed some more methodological sorry, I needed a better way of like finding out what was wrong. So I sat down with TCP dump, which is TCP is the transmission control protocol, which allows for clients to have data transfer. For those of you who might not know what it is, but it makes it so that you can have like yeah, never mind. So basically, I sat down with the TCP dump tool and obtained a packet trace of the data, and I started graphing it with this tool called TCP trace, and just like sort of explore what could be wrong, what can I find anything that reveals what's wrong, and yeah, I mean. So this graph, I hope you can see it. It's a little bit on TCP trace doesn't really make graphs that well. But so what you see here on this graph is like, so it's a time on the x-axis and then segment size on the y-axis. And so the segment size, the TCP connection is comprised of several packets that are ordered, and each of the packets have a maximum size that it can have. And so the topmost line, if that's visible to you, that is the maximum size. And then you see a lot of spikes in the middle. You see a lot of jumping up and down in the middle, and that's just because there's a loss in transmission. I think I made this graph on a Wi-Fi, so sometimes you get these graphs. But what's most significant here is that you see the requests like the response time is or the requests response time is on the x-axis, and it says 6.5 seconds roughly. So it takes 6.5 seconds to complete this particular request, which involves uploading a 65 megabyte PDF through Donkey. Now, this is the segment size. This is the equivalent graph only when made with HTTP2, and so it says the last number down there says 25 seconds, but yeah, so this is roughly 30 seconds. And so this is not even the full graph. There is something missing. I had to cut it off. I've zoomed in, and you see like this sawtooth pattern. And so that was the first time where it's like, okay, there's something wrong. So what this graph actually says is, it says that the client gets to transmit packets in bursts, and then it gets told you can't, it just stops transmitting. So rather than just sending packets back to back, which TCP normally allows, you're told it's constantly stopping. So it's sort of like, it's like constantly halting and not being able to use the TCP congestion control mechanisms that facilitate sending data back to back in a proper way. And it was like, I gotta look more into this. Like, this is there must be something wrong with their implementation, because this was regardless of where I was, where I was located, what type of connection, which client I was using, like all these things. I could repeat it whenever. So at this point, I'm still mentally here. I'm still in the process of convincing someone else that my software is not performing badly. So this is what and doing so on the side, not like as my primary task. So it was a little bit like, have you found out what's wrong? No, it's a little bit aggravating. But I got to study the HTTP2 protocol, which I've heard about on multiple occasions, but I hadn't really looked further into it. So basically, it's an attempt at fixing or facilitating the modern web. Meaning, so what is the modern web? But like most interactions online today are smartphones and people's computer, where they're on Facebook or Twitter or whatever. And so they want to upload a lot of pictures and like create a post on some social media site, while at the same time having an interactive chat connection. And how HTTP2 facilitates this is it opens one connection to the server, but it runs multiple requests in that connection. And so just like with TCP, we now have a congestion protocol inside of HTTP2. So you have streams of frames, and each stream is assigned a specific, each request is assigned a stream. And the streams have associated windows. So the windows are the way that you can say, okay, you can send like so much data, and then I'm gonna cut you off. That's you do that using Windows, the window update frames. And so there's a tool called NG-HTTP1, which is I don't recall NG particularly, but yeah, it's the reference and HTTP2 implementation, and it's what's being used by curl and most major browsers, and maybe Google has their own implementation for Chrome or Chromium, but like most others use the NGHTTP2 library, and like they have a curl-like tool called NGHTTP, and this allows you to obtain a connection trace. And this is, so I've just included a snippet, and it's like a really raw snippet, but basically you see you have some timing information, you have some protocol information, and then there is some messages being sent back and forth. To begin with, we receive a settings frame from the server, and then at the same time, we also send some headers to the server. And what it says open new stream, and then the following part is what's actually the request. So a particular request that is contained in a stream and handled via HTTP2. So I expected to find something like this, and this is the connect. This is a snippet of a connection trace that I've obtained by connecting directly to Donkey over HTTP2. And what you see is we have a stream with the stream ID 13, and my client emits multiple data frames. There's a lot of data going up. I forgot the ellipsis to denote that. But so yeah, so we have packages, frames, each of size 16 kilobytes, except for the last one, which is a little bit more than 4. And then the server sends. That's why it says receive, because the clients receive a window update frame that denotes that the window size increment is 8 million, so roughly a little less than 8 megabytes. Now, that makes my client able to transmit again, and it completely fills the window, and then it sits back, waits 300 milliseconds for a little bit less than 300 milliseconds for a new window update. The reason why we're waiting is because all of these packages have to be acknowledged before being received at the end. So that's why the HTTP2 implementation in the server doesn't respond until after that time. And this is one of the reasons why implementing a congestion protocol in an application layer is bad when TCP already provides it. But yeah. So this is what I found when connecting through the ALB. You see that you get to send one data frame, and then you receive a window update, and then you send one data frame, and you have to wait to receive a window update. And then you get then they're being rather then they're feeling great. So they're handing you a window size increment of 32 kilobyte, which means that you can send 3 data frames, and then you have to wait. And so going back here, you see a direct mapping between the sawtooth pattern that I observed when looking at the connection trace, and how and this behavior. And so I was like, okay, this is it. So I reported this in January 2018. We had our initial correspondences in like medio January, and then our account manager, he told us, yeah, you gotta upgrade. On January 17, he was like, you gotta upgrade to AWS Premium Support if you want to have this case taken seriously. Like, your claim is, you don't have the privileges. You have to escalate to the premium support package. So I guess that's what our CTO did. He was like, okay, let them do it. And then we had a bit of back and forth, and I submitted some more TCP dumps, and the case handler informed us that they would return back. So this is on January 24. That's the last correspondence we have with them for like 6 months. And they were like, we're gonna follow up. And so this was something I did on the side. So quickly time flies. And so, but we never heard anything from AWS. It's like, no. And at some point we had Joachim, who was supposed to talk about Kubernetes. So he starts, and he's starting to, we investigated a little bit, because I remember it. I'm like, have we ever heard back? And so he's like, oh yeah, but you can just disable, there's an option now. And I was like, what, why? There's no option. But so I go in and I find on the GitHub repositories for the SDKs for Go and for JavaScript that they have been updated on February 22nd to include an option that I failed to paste into my slides. But basically it's routing.http2, and then you can enable and disable it. And so this is on February 22nd, and we didn't hear anything about it. And it would have been, by informing us that we had this option to disable HTTP2, we could have enabled the new load balancer rather than using the old one, but they didn't tell us. And so, yeah, so we canceled the premium support. I think we paid it for a while. Actually, it's quite expensive, and like, I guess you get a prize for being stupid enough to pay that. No. Yeah, so again, time flies. We have no time frame on the resolution of this issue, and at this point, we haven't even had any acknowledgement. We were just told that we'd be let know, and now the subscription has been canceled, and it's like, what can we do? So, tying back to the initial, to my initial problem analysis, I found that there were no one else that had reported anything. Like, it was really, really hard to find anything remotely related to my issue. So I just thought that, like, it seemed, at the time, especially in December, it seemed rather, it seemed like it would be, first off, it seemed like it would be a shame to let my efforts go to waste. Obviously, we still had the problems, and it at this time it was apparent to me that no one else had reported this at this time. So I decided I'd make a public reporting about it. I wrote a Medium blog post. So the basis was, of course, the initial report submitted in January, and so I also added a narrative to sort of explain this, and the slides will be online later, and there's a link. You can also find it on my Twitter page, and it contains like the detailed write-up that explains it contains links to the NGHTTP2 side and TCP trace side, and you get much more details from that. And it was a nice exercise to sort of make a write-up that would get indexed. So Medium has this thing where you press share, and I was like, I had never used it before, so I did that, and I had the most boring Twitter posts added to my Twitter account. I was like, okay, so nothing really happened. And then in July, I was like, what happens if I post it on Lobsters? So Lobsters is the crustaceans Hacker News, and so basically Hacker News is terrible, and don't spend time there. I don't. So, but Lobsters is like a community similar to that, link aggregation and commenting site, and it's I figured it's a shot, let's post it there. And then I got like 1,500 reads on the Medium statistics thing. It's like, okay. And eventually it caught wind. I was on vacation in Portugal, and I had an email from my boss about Amazon reaching out. So yeah, the aftermath of this is that after having the publicly denounced their HTTP2 support, they've actually reached out, and they've been working with us. They've been extending their sincere apologies, and they've acknowledged the issue. So this was important. I remember after the meeting, our CTO is like, yeah, you're right. It's like, I know. Like, but apparently, like, he needed that, and so, which is fine, but it's just like, this is what they're holding back. And they've got a preliminary fix that I have tested, and it works. There's like no performance degradations whatsoever now, so that's fine. And we've gotten sizable discounts on our AWS bill, so I don't know, maybe I should get a raise. And so for the technically inclined, what they did was they, if you remember the snippet before, they proactively emit window update frames ahead of time. So the reason why we have the sawtooth pattern is that the client quickly exhausts its allowed window of packages, and then it has to wait for the HTTP2 server to respond back and say, hey, you can send some more. So now if they are able to handle more data, they will just send you new window update frames. And so they will send them with various window size increments. But particularly, the client will never exhaust its window unless there is a reason to it, and that will prevent the sawtooth pattern behavior, the stop and go behavior. So that's it. Thanks for coming.
Any questions?
So I didn't quite catch if you mentioned it, but why were you the only one to encounter this issue? This sounds like a general problem with the HTTP2 implementation.
There is, I guess this, what Amazon, so there are multiple questions here. So first, there are multiple answers here. So first, I don't think we're the first ones to discover it, but I think we're the first ones to actually acknowledge, investigate it. Secondly, it only affects clients uploading, so there is no performance degradation when you're downloading, like when a service is streaming something through the LB to a client, there is no degradation. And so Amazon have acknowledged the particular case where it's a problem with the upload only. And then someone wrote a Medium post reply on the post about that they had experienced the same issues, and that they were grateful for our reports. So why is the other question? Like, why is a different question. But I think that most people would just, if you run into this issue and you're faced with AWS support, you're like, okay, you can go to the forum, you can post something, and then, you know, maybe, just maybe someone will say, you did this wrong, or you did this wrong. But acknowledgement on behalf of having a cloud service provider like Amazon acknowledge that there's an issue in their implementation is just extremely hard, as this shows. Even for something with a very simple fix, like this was really simple to fix and simple to acknowledge, in my humble opinion. But yeah, so I guess they just, I think if you run into this issue, you just downgrade, as we did with to the ELB. Good question though.
Any more questions? Well, thank you, Peter.